Let's take a look at how to profile networks and to discover what hosts are present and what services are available on those hosts. To do this, I'll use a tool called Nmap. Nmap is a standard network administrator's utility and runs on many platforms. For this module, I'll be using Nmap on the Raspberry and Linux distribution on my Scorpio computer. Let's get started by installing Nmap. I've got a console window to Scorpio ready to go, so I'll enter sudo apt-get install Nmap and start the installation. Nmap provides a wide range of options to explore networks. Nmap's primary function is to scan a network and probe the hosts that it detects. It can scan using either of the two main Internet protocols, TCP and UDP, and provides a lot of control over how the scanning and probing works. It can access services using a supplied username and password, or it can try to brute force its way in by guessing them. There's also a Windows graphical user interface version of Nmap, and we'll look at that before completing this module. Now I've installed Nmap, I'll demonstrate its basic features. My first goal is to discover what hosts are on my network. I can do this by simply asking Nmap to check the network by entering sudo nmap -sn 10.1.1.1-60. In Linux, some networking functions will only work in superuser mode, so I use the sudo qualifier in front of the nmap command. Nmap has many functions which are selected by using options on the command line. Here I'm using the -sn option, which contacts each host in turn with what is known as a ping to see whether it responds. Nmap reports only the hosts that do respond, as we can see, and also provides the network interface level address, known as the MAC address of the host. I'll not use MAC addresses in this course, but they can be useful in advanced networking. I know already that the IP address space for my local network is 10.1.1.1 to 10.1.1.254. But by typing 1-60, I'm limiting this scan to just the first 60 addresses. The allocation of host addresses is usually done based on subnets, and the number of hosts is usually a power of 2, 4, 8, 16, 32, and so on. I can select a subnet to scan by specifying the number of bits starting at the beginning of the address, which are the same. Here, /26 selects 64 addresses, 0 to 63, although for practical purposes the address.0 is ignored. This makes managing the address range for the subnet much easier for computers, because this form of specification enables simple binary masks to be used. You will likely see a mask specified in your home network router as 255.255.255.0. That's a /24 address mask. Let's use this way of specifying subnets. I'll scan again, but this time using sudo nmap -sn 10.1.1.0/26 to look at 10.1.1.1 to 10.1.1.63. There are a number of other options when doing host discovery, such as taking an input file of host names, excluding specific hosts from a subnet scan, and so on. I won't cover these here, but you can have a look at the full list of options by entering nmap -h. Let's now look at Hydra on IP address 10.1.1.51. We'll drill down deeper into this system using the -ps option. I'll enter sudo nmap -ps 10.1.1.51. Nmap is now checking the most common services. There are currently about 2,200 in its database, to see if they're open on this host. It does this by starting to open a connection to the service and then closing it down before the connection is complete. This is called a TCP SYN ping, and it works by sending an empty TCP packet with the SYN flag set and waiting for the host to respond with the standard SYN-ACK response. While a normal connection would be completed by sending back an ACK, Nmap instead cancels the connection before it completes. We can see in the response that Hydra has 5 services open. Finally, let's use Nmap to drill down into an individual service on Hydra. By using the -sv option, Nmap will try to identify the version of software being used for a service. I can limit the testing to just one service with the -p option. We'll choose the second service shown on the list, the Secure Shell service on port 22. I'll type sudo nmap minus P22 minus SV 10.1.1.51. Nmap comes back and tells us that the service on port 22 is using the OpenSSH version 6.0 P1 software. This is now very rich intelligence. Let's go to the NIST vulnerability database. We can run a search for OpenSSH. We can see there are 76 known vulnerabilities for SSH. As a network administrator, we can now review these vulnerabilities to see whether they're relevant, and if so, make sure we have the correct patches applied to this installation of OpenSSH. So far, we've covered Nmap scanning of TCP ports. TCP is a protocol used where a session needs to be established for multiple message exchanges. TCP is used for protocols such as email, web access, and file transfer. UDP is another TCP protocol which is used where single messages are suitable. The Network Management Protocol, SNMP, is commonly used through UDP. If we want to use Nmap to scan UDP ports, we need to use a slightly different syntax. To do this, I'll enter sudo nmap minus su minus p0 minus f 10.1.1.51. The minus su command will cause Nmap to list all the UDP ports it finds. Minus p0 assumes that Hydra is online and doesn't run host discovery, and minus f is a fast scan of a limited number of ports. The scan is now finished, and we can see the list of open UDP ports and the associated services. Nmap can also check multiple port ranges for both TCP and UDP. So let's try that by entering sudo nmap minus s su minus p u colon 53, 111, 137, t colon 21 to 25, 80, 139, 8080, and the host address of 10.1.1.51. The command minus s su specifies both TCP and UDP, and the minus p value requests UDP ports 53, 111, and 137, and TCP ports 21 to 25, 80, 139, and 8080. The results show the response for all of the requested ports as either open or closed. Finally, let's type sudo nmap minus ps minus o 10.1.1.3 and press enter. In this example, I'm using the -o option in addition to the normal TCP port scan option to check what kind of operating system is being used on the computer I'm using, which I know has the IP address 10.1.1.3. The scan has now finished, and Nmap has fingerprinted my computer. Nmap offers many more options, and it's fun trying them out. I'll now look at a graphical version of Nmap called Zenmap, which comes as part of the Windows Nmap installation. While Zenmap provides a graphical interface, it still creates and displays the same command line that I've been using in Nmap. At the top left, the target is the specification of the host or subnet to investigate. So let's make our target 10.1.1.0/26. I don't want to do an intent scan, so let's select a ping scan from the profile drop-down. And we can see how Nmap has created the command line nmap -sn 10.1.1.0/26 in the same way as we would have typed it in at the command line. Okay, let's go ahead and scan. We can see in the left-hand panel the list of hosts that have been detected, and the standard scan output in the right-hand panel. The Host Details tab displays information on whichever of the detected hosts we select, and allows notes to be added to the host record. Let's select 10.1.1.51 and add a brief note that this is a Raspberry Pi. The Scans tab provides a record of the scans that have been run this session. Now let's make the target Hydra, and using the Profile drop-down, select Regular Scan and start the scan. The scan is finished, and we can see that the output is exactly that which we'd see at the command line. If we select Hydra in the hosts list and then select the Ports Hosts tab, we can see the ports which Zenmap has detected. Let's now do a more detailed check of Hydra by selecting an intent scan from the drop-down and running the scan. The scan is now completed. The intent scan provides a lot of information. Let's scroll up to the top and look at it. The first section shows the open ports that have been discovered, as we saw in the earlier scan. Then we see the OS detection scans starting, and following this, a more detailed scan of each service to determine the software version. The MAC address is found and matched to the Raspberry Pi Foundation. Below the line starting with OS, we see that the operating system is a Unix or Linux distribution. This is then followed with an analysis of the system using NetBIOS probes, which has discovered the host name of Hydra and that it's running the Samba 3.66 version of SMB. Finally, let's go back and look at the Topology tab. This provides a graphic of the 4 hosts that have been detected. I'll expand this with the fisheye view. More usefully, the host viewer provides a tabbed summary of each host detected. Let's select 10.1.1.51 and see what information we've captured. We can see some basic configuration information, including the version of Linux that's running. And again, we can see the services open on this host. In this module, I've used Nmap and its graphical variant Zenmap and demonstrated how to use them to conduct host and port scanning, including drilling down to find out the most likely operating system and version of software running on each exposed service. This provides a great profile of the network for administrators to use when designing their protection strategy.